Hi everyone, and welcome to my channel, GeoElmo Geocaching. In this second episode of my high altitude balloon series, we're going to be talking about balloons. If this is your first time joining me in this project series, then welcome. Above is a link to my high altitude balloon project intro video, which will catch you up on what I'm planning to do and how it relates to geocaching. In this episode, I'll be talking about the following: the role of the balloon in the high altitude balloon project, the science behind helium balloons in general, the science behind high altitude balloons, the types of high altitude balloons that you can choose from, and I'll answer the question, how much helium am I going to need? There are links to informational articles I used in my research in the description section of this video. So what is the role of the balloon in a high altitude balloon project? In short, the role of the balloon is to lift a payload high into the air. At a high altitude, the balloon will burst, and a parachute will safely bring the payload back to the Earth. It sounds simple, but there's a lot to know about balloons, and I found the science behind it to be fascinating. Have you ever wondered how helium balloons work? Yes, you inflate a balloon, you tie off the end, attach a string to it, and then it floats over your head as you walk around. And if you let go of the balloon while you're outside, it will float away, never to be seen again, which has led to many crying children. But why do balloons act this way? Let me explain. Have you ever tried to hold a ball underwater while swimming in a pool? What happens? The ball tries to force its way back up to the surface. If you let go, the ball will quickly rise to the surface and float on top. The reason that happens is because of displacement and buoyancy. When you hold a ball underwater, the ball pushes an amount of water equal to its volume out of the way. Pushing the water out of the way is called displacement. Where there used to be water, there is now a ball. You won't notice displacement in something as large as a swimming pool, but you will if you drop something that sinks into something smaller, such as a drinking glass or a beaker. The water level will rise by the amount of the volume of the object that you dropped in. Now, if you measure the weight of the ball and the weight of the water that was displaced, you'll find that the weight of the water weighs more than the ball. Because the weight of the ball is less than the weight of the water that it displaced, the ball will float. This is the law of buoyancy. Archimedes' principle states that an object immersed in a fluid experiences a buoyant force that is equal in magnitude to the force of gravity on the displaced fluid. In other words, while the ball's weight is pushing it down into the water, the buoyant force, which is equal to the weight of the water, is pushing the ball out of the water. Because the buoyant force is greater than the weight of the ball will rise to the surface and float. A key term in Archimedes' principle is the word fluid. We know that liquids, like water, are fluids, but did you know that gases, like air, are also fluids? Because both water and air are fluids, the same principle applies to a ball in water as to a helium balloon in air. This helium-filled balloon displaces a volume of air. Where there used to be air, there is now a balloon. The weight of the helium-filled balloon is less than the weight of the air that it displaced. The buoyant force is stronger on the balloon than its weight, which will cause the balloon to float, just like the ball that was submerged under the water. Pretty cool, right? Now that we understand why helium balloons float, let's talk about how high-altitude balloons work. When a balloon is inflated, there are several forces at work. The increasing pressure as we inflate the balloon causes the balloon to expand. The helium pressure inside the balloon is greater than the air pressure outside the balloon, which is why a balloon will pop when it is stuck with a needle, or it'll deflate when the end is untied. When a balloon is tied off, there is an equilibrium of pressures. The helium pressure inside the balloon is equal to the air pressure outside the balloon, plus the elastic tension of the balloon trying to deflate itself. Unlike a helium balloon for a birthday party, a high-altitude balloon is not fully inflated before it is launched. That's because as a high-altitude balloon rises in altitude, the air pressure outside of the balloon decreases. Per the ideal gas law, when the air pressure decreases outside the balloon, the volume of the balloon will increase, which also lowers the pressure inside the balloon, forming a new equilibrium. Eventually, the high-altitude balloon will not be able to expand anymore, and it will burst. The more the high-altitude balloon is inflated on the ground, the lower the altitude at which it will burst. Let's take a look at some sample data from the UK High Altitude Society website and use a 600-gram balloon as an example. These values were generated using hydrogen, not helium, but they give a good indication of the difference in a balloon between launch and the time it bursts. For a targeted burst altitude of 30.8 kilometers, which is 101,000 feet, the diameter of the balloon on the ground will be approximately 142 centimeters, which is 55 inches or just under 6 feet. When it bursts, the diameter will be approximately 602 centimeters, which is 237 inches or just under 20 feet. So the balloon will expand from 6 feet to about 20 feet. That's a big increase. Balloons are sized by the weight of the balloon in grams, and they're manufactured by many different companies. High-altitude balloons are made of latex, and while the different sized balloons are about the same thickness, the larger balloons will expand to a larger diameter before bursting. Some common sizes are 350 grams and 600 grams, but there are many different sizes to choose from. In general, the larger the balloon, the higher the burst altitude of that balloon. Using the data we looked at before, my initial plan is to use a 600-gram balloon to take the payload to about 100,000 feet. So how do I know how much helium I'm going to need to launch my balloon to the targeted burst altitude? There are several online calculators we can use. I'm going to show you one from habhub.org. With this calculator, I can choose the mass of my payload and a balloon I plan to purchase. I can then enter a target burst altitude or ascent rate and get a bunch of valuable information. A target ascent rate should be between 5 and 6 meters per second. Anything lower and the balloon may not burst. That, along with your target burst altitude, will be part of how you determine which balloon you will choose to use. I currently don't know the mass of my payload, which includes the parachute and the rigging. Let's use 1 pound as an example, which is about 454 grams. Entering this data gives me the following information. Volume shows how much helium will be needed. The neck lift tells me how much lift the balloon will have when filled with a given volume. If you attach something of this weight to the balloon will float in place without going up or down. You can see that this doesn't meet the targeted ascent rate, but bumping up to a 700-gram balloon will meet that rate, as well as require more helium. Once I plan out my payload, I will revisit the site to help me choose the correct balloon size. Please note the amount of helium needed, which will most likely require a tank larger than can be rented at a party store. My plan is to purchase 2 balloons and to have the capacity to inflate both, just in case one bursts before launching. This concludes the video about the balloon portion of the high altitude balloon project. I hope you found it interesting. I really enjoy learning so much about this subject. Please don't forget to subscribe for more videos about this Geocaching Trackable to Space project or about geocaching in general. If you have any questions or comments, please leave them in the comment section of this video. Thank you for watching.